notation. So we're not going to worry about this first part. We will skip down to the polynomials bit here. So a review of polynomials. This is the definition of a polynomial. I do not expect you to remember that. All right. What you're used to seeing is something more like this. F of x is equal to 7x cubed plus x to the 4 minus 8x squared plus 5. If I say, what is the degree of a polynomial, what am I asking? You don't have to raise your hand. You can just yell at the answers. The degree. Well, what's the degree of this polynomial? It's the highest exponent. So you look at each individual term. Terms are separated by addition or subtraction signs. So that's a term, that's a term, that's a term, that's a term. The one with the highest degree or the highest exponent is the degree. So in this case, the degree is 4. What is the leading coefficient? 7. You want to say 7? Because the way they wrote it and the word leading. But when they say the leading coefficient, it is the number in front of the term with the highest degree, which in this case would be 1. They wrote it this way to basically trick you. Most times, if you're going to write a polynomial out, you start with the highest power first. But they wrote it this way to illustrate a point. The constant term is 5, the one with no variable. Okay. Yeah, 1 page done. Whoops. All right, linear. This is grade 10. If this all seems a bit like it's not instantly coming back, don't worry. I'm not worried. I know you haven't taken math. If you were in the Octa system last year, your math 11 could have been like September, October last year, and then so we're like a year and a half away. That's fine, okay? A linear function is basically the mx plus b stuff. Remember that from grade 10? What is m? What does m stand for? M is your slope, which is what over what? Rise over run. Okay, what is b? Y-intercept. That is the y-intercept. How do you know if something is a linear function? Like, how do you know if it's a straight line? By looking at the equation, I guess that's what I should say. Like, if I gave you, let's write it on here. Well, these ones. If I gave you that, let's look at this in the bottom for a sec. What shape is that? This is grade 11. It's the parabola, right? And you know it's a parabola because it has a degree of 2. Okay? It's called a quadratic. We'll look at those in a sec. So how do you know if something is linear?
If it doesn't have a degree?
It does have a degree. What is the degree?
1.
Yes. If it has a degree of 1, it's a linear function. Okay? And do you know what I mean by linear? It's a straight line. Yeah. Degree is equal to 1 equals linear. Okay, so if I asked you to sketch 3x plus 1, we're just sketching here, okay? What is my slope? M. What is my slope from the equation? 3, right? The number in front of the x. The m is in front of the x. So it's 3. I'm going to write it as 3 over 1, okay? Because I want rise over run. What's my y-intercept? 1. So if you're going to sketch this graph, you mark the y-intercept, which is 1. And remember, this is your x, and this is your y-axis. Y-intercept is 1. I'll just guess where 1 is. Doesn't matter. The slope is 3, which is rise over run. So you'd go up 3, 1, 2, 3, and over 1. And you just draw a straight line through the points. That's all I would expect. Unless I gave you an actual proper grid and everything, but it was just a sketch. Is that okay? All right, let's talk about domain and range. Remember the word domain? Remember vaguely hearing it sometime in your mathematical past? What does domain mean?
The restrictions of x.
Yes, it's what x is allowed to be. All right? You're going to see that becomes important as we go through this course. The only time you have restrictions on x are 2 cases. One, and where can I write this? If you have, we're going to keep coming back to this, so it doesn't really matter if you write this down. So restrictions on x. If you have a square root, because what numbers are you not allowed to square root? Negative numbers, right? So in this case, x would have to be a positive number. So you have restrictions if you have a square root, or you have an x in the denominator, like that. Because what number are you not allowed to divide by? 0. So in this case, x could not equal -1. That's an equal sign with a slash to it. That was weird. X could not equal -1, and in this case, x would have to be greater than or equal to 0. We will come back to the notation and all that kind of stuff in a sec here. All right? We don't look at those type of things until later on. All right? We will come back to those restrictions. But that's the only time you have restrictions. So looking at this, do I have a square root? No. Do I have an x in the denominator? No. So if you have no restrictions, you write, there's 2 ways to write it. The domain, so D for domain. You could write, and this is what they usually write in the lower grades, they'll say XER. Remember seeing that somewhere? X is all real numbers. As you move up in math, they tend to write it a different way. So they will write the domain is -infinity to +infinity, which means it's everything. I don't care if you give me XER or -infinity to +infinity. Doesn't matter to me, right? This needs to be round brackets because that means it does not include the number. I'll talk more about that in a sec, or as we move through the course. What about the range? And you can look at the graph. Look at the graph. There's no holes or anything like that in the graph. It just goes on forever in both directions. So what's the range of this? Are there any restrictions? Sorry, what does range represent? Start with that. It's the y values. Restrictions on y. Are there any restrictions? Like what would be the domain or the range of this graph, this function? YER. Because it can be anything. If x can be anything, y can be anything. Well, that's not always the case, but so we'd write -infinity to +infinity. Okay. Don't worry too much about domain and range right now. It'll just kind of be baked into the course as we move through it. Y is equal to 5. What does that graph look like? Yes. So you could write it like this. 0x plus 5, right? Because 0 times anything is 0. So that would just give me y equal to 5. I should put an equals there. In this case, you can see the slope would be 0, the y-intercept would be 5. If the slope is 0, it's a flat line. Okay, so it just looks like that. What is the domain of this function? Are there any square roots in the function? Are there any x's in the denominator? So then what does it have to be? XER, all real numbers. So, or negative infinity to positive infinity. Oh. What's the range of that graph? Sorry? Yeah. The only thing it ever is 5. It's just y is equal to 5. All right. Okay, that's basically, that was math 10. All right. Quadratics is math 11. Basically, it's like half of math 11. It's just like quadratic, quadratic, quadratic. And you know it's a quadratic when the degree is 2. Okay. If I said, sketch this, y is equal to x squared. What does that graph look like? And where is it? Yeah, right at the origin. Looks like that, right? What do you call this shape? Parabola. And then what you did in grade 11 is start to move these graphs. Negative x squared. What does that do?
Just that, but upside down.
Yeah, flips it so it opens down. All right. Oh, sorry. So there was 2 forms you learned in grade 11. There's general form, which there's the I don't want to say general, but the form that covers all applications, which is the normal polynomial form, right? Written like this. In grade 11, you learned how to turn that into the standard form, which gives you P and Q. What were P and Q? Does anybody remember? The vertex, exactly, which is the bottom of it, right? Or the top of it, I guess, depending on which way it opens. We're not worried about standard form in grade 12. I mean, you might see it, but it's not really how to convert back and forth. I'm not going to ask you that. We're going to focus more on the general form. So here's my general form of this equation: x squared minus 3x minus 18. Sorry. If I say, well, let's go down here. Whenever you get a quadratic function in this class, and they will keep coming back, one of the first things you will do is to factor it. Okay? So, does anybody remember how to factor a quadratic that looks like this? And by factor, I mean you're basically turning it into the double brackets, right? You're going to rewrite it as that sort of thing.
You get 2 numbers that multiply into 3 and add to 18. Here's the opposite. Opposite, yeah, figured that.
Two numbers that multiply to the last term, negative 18, and add negative 3. Well, multiplies to negative 18 and adds to negative 3.
6 and 3.
Which one's negative?
The 6.
6. So, x minus 6, x plus 3. You need to be able to factor in this class. All right, and not just these kind. Well, I'll go through the other kinds where you have like a 2 or a 3 a value in front there. You need to be able to factor. Because when we get into like trigonometry stuff, which is later on in the course, all that kind of junk, you will see quadratic trig functions, which the first step is to factor them. All right? You have to be able to factor. And if you can't factor, please come see me, or you need to review. I can give you a review. Okay, so we factored x minus 6, x plus 3. Now they're asking for the zeros. If they, in a different, what's another way of saying 0? What am I really asking for there? Whoever said that. X-intercepts. Yes. Zeros are x-intercepts. So the reason we factor is because it's easy to see the x-intercepts. The x-intercepts are what make each bracket 0. So what makes this bracket 0? Positive 6 and so your zeros or your x-intercepts are 6 and 0. And the reason I'm writing them as a coordinate pair, so it's x, y, is because the x-intercept is when y is equal to 0. Okay? And negative 3, 0. We're not going to worry about the vertex. It's grade 11. There's a that involves converting it to standard form. I don't care about that. The y-intercept. So if the x-intercept is when y is 0, the y-intercept must be when the x is 0. The easiest way to find the y-intercept is if you go to the original. Don't go. I mean, you can go to the factored form if you want, but if you go to the original, and I put 0 in for all my x's, what am I left with? Negative 18. Whatever the constant term is your y-intercept. Okay, so the y-intercept is negative 18. Okay, we can sketch this graph. So we mark the x-intercepts, 6 and negative 3. 6, there's 6, whoops. Negative 3. The y-intercept is at negative 18. I'll just say negative 18. I'm just guessing where these things are. Does this graph open up or down? Why do we know that it opens up? How do you know that? I guess. Yes, you're right. How can you tell if it opens up or down just by looking at the equation? What's not negative? Yes. So you remember this one up here? Has a negative in front of the x squared. If there's a negative sign in front of the x squared, it opens down. If it's a positive in front of the x squared, it opens up. You are right that the vertex is at the bottom and it's negative 18, so that's another way to tell. But just looking at the equation, that would be it. Okay, so it opens up, goes through those points. That's all I expect you to do. Mark the x, y intercepts, and does it open up or down? Okay. I don't care about the vertex. We could find it by averaging the x-intercepts, but I'm not going to worry about that. Domain. We're not going to do range because we need to know the vertex. So what's the domain of this graph? Why is it XER?
It opens up.
So if it opens.
There's no restriction to it, I guess.
Yes. So remember what I said up here? You have domain restrictions if you have a square root with an x inside of it, or you have x in your denominator in the bottom of the fraction. We do not have any of those in our equation, therefore it is XER, or negative infinity to positive infinity. All right. Just sort of triggering awesome memories from Math 11 and Math 10. Yeah. Or just horrendous memories from Math 11 and Math 10. Or just shut up, Baldwin, and teach us the rest of the class. All right. Okay, so do you have space at the bottom of your page like I do? Okay. What does that graph look like? There you go. It's been shifted one up. Right? I guess I should have done this. We had it at the top, but x squared was centered at the origin. If I put a plus 1 on the outside, it just moves the whole graph 1 unit up. Okay? What about that one? Negative x squared minus 1. Okay, so what does the negative in front of the x squared tell you? It's going to open down. What does the minus 1 tell you? Let's move 1 down. So you always start with the basic here. This negative 1 will move it 1 down. The negative in front tells you it opens down. All right. What about this? So now I've put a plus 1 inside the brackets with the squareds. What does that do to the graph? Well, what did it do when it was outside? Outside the x squared, it moved it up. It's outside the x squared, it moved it down. So that's moving it up and down, right? As soon as I put it inside with the x, and it's all squared, it should move it left or right. So which way do we go if it's plus 1? All you have to do is ask yourself, what makes the inside 0? What would make the inside of this 0? Negative 1, right? So you've got 1 unit to the left. It's at negative 1. It tells you what your x-intercept is. So negative 1, does it open up or down? Up, because it's positive. All right, last one before I give you some practice. Can you sketch that graph? I'll give you a chance to sketch it, and then we have it. Are you ready? you get that? Zoom in on it. So, what makes the inside of this 0? Positive 2, right? So that means we went 2 to the right. What does this negative 1 do? That moves it 1 down. There it is right there. And this forces it to open down. Does that make sense? Okay. What is the domain of this graph? Remember, when I ask you domain, what 2 things do you have to look for to see if they're in the function?
Denominator with x and square root of x.
So you have a denominator with x in it. Do we have a denominator with x in it? No. Do we have square root? No. So then what's the domain?
X and y.
All real numbers. Okay. Here's your question. What's the range? So what's the highest y value it can be?
Negative
-1, right? It's right there. Does it open up or down?
down.
Down. So it's all the numbers that are less than -1, right? So there's 2 ways to write that. There is the grade 10, maybe grade 11, I don't remember. You would say y is less than or equal to -1. Remember seeing that kind of stuff? Okay, that's fine. People tend to mess up the greater than, equal to, less than, all that kind of stuff sign. The other way to write it is the interval notation. So the lowest number comes first, okay, when you're writing interval notation. Like if you look here, negative infinity is smaller than positive infinity, all right? So smaller number, larger number. Okay, so if I'm going to write it in interval notation, let's look at the higher number. What's the highest the y value can be? -1. So that's going to go on the right. -1. What's the lowest that the y value can be? Negative. Yeah, because it's just going down. Does that make sense? So the lowest it can be is negative infinity. Now, look, this is not a class on infinity. This is not calculus. But just so you understand, can you ever reach infinity? What does infinity mean? This is like a bigger question. It basically means it just goes on forever, right? But in this case, in the negative direction. Okay? You can never get to infinity. Like when people, like when I was a kid, people would be like, it's infinity. Oh, well, it's infinity plus 1. Shut up. You can't get to infinity, okay? It's all the same. So, because you can never get to it, it is a rounded bracket. That means it does not include the number, okay? Rounded bracket means, and I'm not going to test you on this. It's just kind of helps as we move through the class. Does not include number. So that's like your less than sign or greater than, all right? Now, is -1 part of this graph?
Yes.
Yes, it is. So when you include the number, you use a square bracket, okay? So a square bracket means it includes the number. So that is your less than or equal to, or your greater than or equal to sign, okay? So this is includes, and this is does not include. This is not a course in this kind of notation. In calculus, this becomes more important. But just so you know, you should be able to do domain and range. I don't care if you use this notation or this notation, okay? but it'll be sort of woven throughout the course. I don't expect you to know this right now, but just so you know, a round bracket means it doesn't include the number. Infinity always has round brackets. That's why they're round here. And if it includes the number, it's always a square bracket. All right. I've done too much talking. Does anybody have any questions? Was that mostly a review? Hopefully. Get your brain thinking about math again. Okay. I only want you to do, and we're going to continue on in this lesson. I just want you to do, you know what? So numbers 1, A, B, and C. So I realize not everybody's used this book before. So if you scroll to where it says assignment on page 5, all I want you to do is sketch those 3 graphs, okay? And don't worry about range. Give me the domain and the zeros, i.e. x-intercepts. Is that okay? Go. And I still got a little bit more to do, but I will come back to that. Okay. If you're given a function, f of x is equal to x squared plus 4x plus 5. And I say f of 2. Where does the 2 go into the function?
Where the X's are.
Yes, whatever's in the brackets, this 2, dumps into every single x. If there's multiple x's, you put it into every x. So we get 2 squared plus 4 times 2 plus 5. And then you basically just simplify it. So what's 2 squared? 4. 4 times 2. 8 plus 5 gives you 17. Okay. What if I put a 2 in front of f of x? What do I do? You multiply the whole thing by 2, right? Because if f of x is this, and I just say 2 times f of x, that is just 2 times x squared plus 4x plus 5. So you just dump the 2 into everything. 2x squared, 8x plus 10. Good? All right. Next one, f of 2x. So where does this 2x go? Yes. Wherever there's an x, you put a 2x. And please bracket everything. So instead of writing x squared, I write 2x all squared plus 4 times 2x plus 5. And now you expand it. What is 2x all squared? 4x squared. Whoops. And then 4 times 2x is 8x plus 5. There's no like terms, so I can't really do anything else with that. All right. All right, D, f of x minus 2. What am I doing?
You subtract 2 from the 5.
Exactly. It's f of x, which is this. So that's x squared plus 4x plus 5. And then we just tack on a minus 2 at the end. You have like terms, the 5 and the 2. So it simplifies to plus 3. That's all you can do. Can't do anything else. Oh, excuse me. All right, and then we got f of, you know what? We'll come back to E. Let's do f first. F of negative x. Where does the negative x go? wherever x is. Now, this is why we want to add brackets, because I replace all the x's with negative x. And this is where the signs can flip. If you don't, you'll get the signs wrong if you're not careful. What is negative x all squared?
X squared.
Just x squared, right? Because when you square a negative, or you multiply a negative times a negative, you get a positive. So it's just x squared minus 4x plus 5. And the last one for today, f of x minus 2. So where does the x minus 2 go? Wherever x is. So that means we're going to get x minus 2 all squared plus 4 times x minus 2 plus 5. Now, this is the mistake that everybody does. X minus 2 all squared is what? Who wants to say x squared minus 4? That's awesome if you don't. Okay? Because it's not. What does something squared mean? If I square 2, what am I actually doing? If I say 2 squared, what am I actually doing? You're doing 2 times 2, right? So if I say x minus 2 all squared, you're actually writing x minus 2 times x minus 2. Which means you're going to have to do what? What do we call it in grade 10 or whatever you learn it? Grade 9.
Foil?
You foil it, right? You have to multiply everything in the first times everything in the second. I'm going to do the 4 too here. So I'm going to get 4x minus 8 plus 5. But if I'm going to foil this, remember, and you don't have to draw the arrows, and you don't have to write it all up. You can do it in your head. More power to you. That's awesome. I'm just doing this because this is a review. So I'm going to write it all out. I'm going to get x squared minus 2x plus 4 minus 8 plus 5. Does that make sense how I got that? Okay, so what do I do now? Just simplify this. Combine your like terms. So we have an x squared at the beginning. Is there any other x squared in there? No, so it's just x squared. We have negative 2x and negative 2x. What's that? Negative 4x. Plus 4x is no x's. They all go away. What's 4 minus 8? Negative 4 plus 5? 1. So it's actually just x squared plus 1 is what it simplifies to. Why are all these people standing out my door? Okay? So just be careful when you have a binomial here to watch the expansion. All right? Questions I would like you to do are number 5, and 8, and 9, and that's it. 5, 8, and 9, please.